The universe has a way of whispering its greatest secrets in the quietest corners. Picture this: you're floating in the void of deep space, surrounded by what seems like endless nothingness. No stars, no planets, just an eerie, almost deafening silence. But here's the twist: that silence is an illusion. Scratch beneath the surface, and you'll find a cosmic carnival of bizarre, unexplained phenomena that leave even the brightest scientists scratching their heads. These aren't just random oddities, they're clues to the universe's deepest mysteries, hidden in plain sight where we least expect them. Take a moment to think about how unsettling that really is. We're used to the idea of space as a place of grand spectacle: exploding stars, swirling galaxies, black holes devouring everything in their path. But the quietest regions, the ones we've written off as empty, uneventful, that's where things get truly strange. Imagine radio signals that appear and vanish without a trace, or ghostly structures stretching across light years with no clear origin. These aren't science fiction, they're real, they're out there, and they're rewriting what we thought we knew about the cosmos. So why does any of this matter? Because every time we uncover one of these cosmic riddles, it's like peeling back another layer of the universe's grand design. These 28 phenomena aren't just curiosities, they're invitations to explore, to question, to marvel at how much we still don't understand. And that's the real magic here. The more we learn, the clearer it becomes. The universe's quietest corners are its most profound storytellers, so buckle up. We're about to dive into the strangest, most mind-bending mysteries lurking in the silence of space, and by the end, you'll never look at the night sky the same way again. The Great Cosmic Void is one of the most baffling mysteries in the universe, a gaping emptiness so vast it defies everything we thought we knew about how space is structured. Imagine a bubble stretching over 1 billion light-years across, containing almost no galaxies, stars, or even traces of cosmic dust. That's the Boötes Void, a silent desert in the cosmos that makes even the emptiest stretches of space look crowded by comparison. Now, here's what makes this truly mind-bending. According to our best models of the universe, matter should be distributed fairly evenly, with galaxies forming a vast cosmic web. But the Boötes Void ignores those rules completely. It's as if someone took a giant eraser and wiped away a chunk of the universe, leaving behind an eerie, unexplained blankness. Scientists first stumbled upon it in the 1980s, and ever since, they've been scrambling to figure out how such a void could exist. One leading theory suggests dark energy, the mysterious force accelerating the universe's expansion, might have pushed matter out of this region, leaving it barren. Another idea proposes that the void isn't empty at all but filled with an invisible form of matter that doesn't interact with light, making it undetectable to our telescopes. There's even a wilder hypothesis that this void is the scar of an ancient collision between our universe and another, a cosmic crash so immense it cleared out everything in its path. What's truly fascinating is that the Boötes Void isn't just an anomaly, it's a challenge. Its existence forces us to rethink how galaxies form, how matter clumps together, and even the fundamental nature of dark energy. If voids like this can exist, what else have we missed? Every time we peer deeper into the cosmos, it reminds us that the universe is far stranger, far more mysterious than we ever imagined. And the Boötes Void, it's just the beginning. While the Boötes Void leaves us staring into cosmic emptiness, the universe throws us another curveball, this time in the form of explosive radio signals that appear and vanish in the blink of an eye. Fast radio bursts, or FRB, are among the most energetic and mysterious phenomena ever detected. Imagine a flash of radio waves so powerful it outshines entire galaxies, lasting just milliseconds before disappearing without a trace. Some of these bursts even repeat, firing off signals in unpredictable patterns that defy explanation. What makes FRBs so puzzling isn't just their intensity. Some release more energy than our Sun does in 80 years, but where they're coming from. These signals travel billions of light years across the universe, passing through galaxies and magnetic fields before reaching our telescopes. And yet, despite their incredible journey, we still have no definitive answer for what's creating them. Theories range from the plausible to the extraordinary. One leading idea points to highly magnetized neutron stars called magnetars, whose violent starquakes could unleash these bursts. Others suggest colliding black holes or exotic cosmic strings, hypothetical defects in the fabric of space-time. Then there's the more speculative possibility. Could these be signatures of advanced alien civilizations, intentionally or accidentally broadcasting signals across the cosmos? Here's where it gets even stranger. Some repeating FRBs follow no discernible pattern, flaring up at random intervals, while others have been caught in precise, periodic cycles. It's as if whatever's producing them is following rules we don't yet understand, or perhaps breaking them entirely. Every new detection adds another layer to the mystery, forcing astronomers to rethink what's possible in the universe's most extreme environments. One thing's certain, these bursts aren't just cosmic static. They're messengers carrying clues about the distant reaches of space, the nature of matter, and even the structure of the universe itself. And with every burst we detect, we're one step closer to unraveling one of astronomy's greatest enigmas, or stumbling upon something even more extraordinary. Just when you thought the universe couldn't get any stranger, along comes dark flow, a phenomenon so unsettling it makes even seasoned cosmologists pause. Picture hundreds of galaxy clusters, each containing thousands of galaxies, all drifting in the same direction like leaves caught in a cosmic river. But here's the catch: there's no visible current pulling them. No supermassive black hole, no known gravitational force, just an inexplicable tug toward something beyond the edge of everything we can see. This isn't just a subtle motion. These clusters are racing at speeds of over 2 million miles per hour, all aligned toward a single point in space near the constellations Centaurus and Vela. When scientists first detected this in the 2000s, it sent shockwaves through the astronomy community. According to our standard model of the universe, matter should be moving randomly, spread evenly by the expansion of space itself. Dark flow defies that completely. It's as if the universe is whispering that there's something vast and unseen out there, something beyond our cosmic horizon, exerting a gravitational pull so immense it's bending the rules of physics as we know them. So what could possibly be causing this? One radical theory suggests these galaxy clusters are being drawn toward an enormous concentration of mass, a structure so colossal it lies outside our observable universe. Think about that for a moment. The observable universe spans 93 billion light-years, containing everything we could possibly detect. But dark flow hints that there's more, perhaps even other universes or dimensions tugging at ours from the shadows. Another possibility, the remnants of a pre-Big Bang reality, a relic from a time before time, whose gravitational echoes still ripple through our cosmos. What makes dark flow so electrifying isn't just the mystery, it's the implications. If confirmed, it could mean our universe isn't the isolated bubble we thought it was. There might be other realms, other structures, even other physics operating just beyond our sight. Every time we think we've mapped the edges of existence, the universe throws us a curveball, reminding us that the unknown isn't just vast, it's teeming with possibilities we haven't even begun to imagine. And dark flow, it's our first tantalizing clue that the cosmic story is far bigger, far weirder than we ever dared to dream. The cosmic microwave background is like the universe's baby picture, a snapshot of its earliest light frozen in time. But nestled within that ancient glow lies something that shouldn't be there, a chilling anomaly known as the cold spot. This patch of sky, stretching over 1 billion light-years, is significantly colder than its surroundings, as if the fabric of space itself forgot to turn on the heat. At first glance, it might seem like a minor glitch, but this frigid irregularity has sparked one of the most heated debates in modern cosmology. What makes the cold spot so extraordinary isn't just its temperature, it's the scale of the mystery. If this were simply a random fluctuation, the odds of it appearing in our observations are about 1 in 50. That's like rolling a die and getting the same unlikely number over and over. Scientists have scrambled to explain it, and the leading theories sound like something straight out of a sci-fi novel. One camp argues it's the shadow of a supervoid, an enormous, mostly empty region of space where matter is so sparse that light passing through loses energy, creating a cold imprint. But here's the catch: even the largest known void shouldn't leave such a dramatic chill. Then there's the far more provocative idea that the cold spot is evidence of a cosmic collision. Not with another galaxy or star, but with an entirely separate universe. According to some models of multiverse theory, our universe might be one bubble among countless others in a vast cosmic foam. If another bubble universe brushed against ours in the distant past, the energy released could have left behind this eerie cold patch, a cosmic bruise frozen in time. Imagine that for a moment. We might be staring at the fingerprint of another reality, a place with its own laws of physics, its own history, its own version of everything. Of course, not everyone's convinced. Skeptics point out that the cold spot could still be a statistical fluke, a trick of perspective, or even an artifact of how we've mapped the cosmic microwave background. But with each new study, the plot thickens. Recent observations suggest the cold spot structure is even weirder than we thought, with strange ripples and asymmetries that defy simple explanations. Whether it's a void, a multiverse signature, or something else entirely, one thing's clear: this icy enigma is forcing us to question not just our maps of the cosmos, but the very nature of reality itself. And in the grand tradition of astronomy, the deeper we look, the more questions we find. Rogue black holes are the universe's ultimate ghosts, invisible, untethered, and lurking in the darkness between stars. Unlike their supermassive cousins, which sit at the centers of galaxies like cosmic sovereigns, these wanderers are stellar mass black holes, each weighing between a few to a few dozen times the mass of our Sun. But here's the terrifying catch: they don't orbit anything. No star, no system, no companion to betray their presence. They drift alone through the galaxy, utterly silent unless they happen to tear into a passing cloud of gas or an unlucky star, briefly revealing themselves in a flash of X-rays before vanishing back into the void. What makes this phenomenon so chilling is the scale of it. Astronomers estimate there could be millions, maybe even hundreds of millions of these rogue black holes scattered across the Milky Way, far outnumbering the known black holes anchored in binary systems or galactic cores. That means every time you look up at the night sky, there's a good chance one of these invisible predators is sliding past, unnoticed, just a few light years away. Detecting them is like trying to spot a shadow in a pitch-black room. Without light to bend or matter to consume, they leave no trace, but occasionally they slip up. In 2011, scientists spotted a microlensing event, a flicker of distorted light caused by a rogue black hole's gravity warping the light of a background star. That single observation opened a window into a hidden population, hinting at legions of these dark wanderers threading through our galaxy. Theories about their origins are just as fascinating as their stealthy existence. Some could be the remnants of massive stars that exploded in isolation, their corpses kicked into the abyss by the force of their own supernova. Others might have been flung from crowded star clusters or binary systems by gravitational tugs of war, doomed to roam forever. And then there's the spine-tingling possibility. Some could be primordial black holes, forged in the chaos of the Big Bang itself, older than time and waiting to be found. But why should we care about these cosmic drifters? Because they're more than just celestial oddities, they're potential keys to unlocking some of the universe's biggest mysteries. Their movements could reveal hidden pockets of dark matter. Their numbers might rewrite our understanding of stellar evolution, and if they collide, the gravitational waves they produce could ripple through space-time, carrying secrets about the very fabric of reality. The unsettling truth is this: we've barely begun to map these invisible nomads. Every rogue black hole we discover forces us to confront how much of the universe remains unseen. How many silent giants might be gliding right past us, unseen and unknown? And that's the real thrill of the hunt, not just finding what we expect, but stumbling upon the shadows we never saw coming. The Milky Way isn't just a swirling disk of stars, it's hiding a secret so colossal, it took us until 2010 to even notice it. Stretching 25,000 light-years above and below the galactic center, the Fermi Bubbles are two enormous lobes of superheated gas, pumping out gamma rays like cosmic lighthouses. These aren't subtle features. If our eyes could see high-energy radiation, they'd dominate the night sky, each bubble dwarfing the entire Milky Way's visible disk. Yet for all their grandeur, their origin story remains one of the most heated debates in astrophysics. What makes these structures so baffling is their sheer energy. The gas inside is scorching at millions of degrees, and the gamma rays they emit suggest something violent happened here, something capable of unleashing the power of 100,000 supernova. The leading theory, a cataclysmic eruption from Sagittarius A, the supermassive black hole at our galaxy's heart. Picture this: 4 million years ago, while early humans were just beginning to walk upright, our black hole might have gone through a feeding frenzy, devouring an enormous cloud of gas or even a star. The resulting explosion would have blasted jets of energy straight up and down, carving out these gargantuan bubbles like cosmic breadcrumbs marking a forgotten feast. But not everyone's convinced. Some researchers argue the bubbles could be the accumulated shock waves from countless star births and deaths in the crowded galactic center, a symphony of stellar violence written in gamma rays. Others propose an even wilder idea, that dark matter particles colliding in the galaxy's core could have annihilated each other, releasing the energy that inflated these structures. It's a cosmic whodunit with no clear culprit, only clues written in light we've just begun to decipher. Here's where it gets even stranger. The bubbles aren't just glowing with gamma rays, their edges are razor sharp, as if they're contained by some invisible force. That's not how gas usually behaves in space. Left to its own devices, it should diffuse, spreading out into wispy tendrils. The fact that these bubbles maintain their crisp boundaries hints at magnetic fields or fast-moving particles acting like cosmic scaffolding, holding their shape against the void. The more we study them, the more questions arise. Why do the bubbles glow brighter on one side than the other? What caused the ancient eruption, if there even was one? And could this happen again? If Sagittarius truly woke up once, there's nothing stopping it from stirring anew, potentially reshaping our galaxy in ways we can't yet predict. The Fermi Bubbles are more than just a galactic oddity. they're a reminder that even our home galaxy has chapters in its history we've barely begun to read. They force us to confront how little we understand about the violent, dynamic processes that shape the universe, even in our own cosmic backyard. And perhaps most thrilling of all, they suggest that the Milky Way isn't the serene spiral we once imagined. Beneath its peaceful facade, it's a place of titanic forces, ancient explosions, and mysteries waiting to be uncovered. The WOW signal is the closest thing we've ever had to a cosmic hello, a burst of radio waves so peculiar it left astronomers speechless. On August 15, 1977, Ohio State University's Big Ear radio telescope picked up a signal unlike anything before or since. For 72 seconds, it blared at a frequency of 1,420 megahertz, a range where natural cosmic noise is virtually non-existent. The signal was so intense that researcher Jerry Amon famously circled it on the printout and scribbled "Wow" in the margin, giving the phenomenon its iconic name. And then, just as suddenly as it appeared, it vanished, never to be heard again. What makes this signal so electrifying isn't just its strength, but its precision. It matched the exact frequency of hydrogen, the most abundant element in the universe, and a logical choice for any civilization trying to announce its presence. Think of it like tuning a radio to the universe's most obvious channel. The signal also originated from the direction of the constellation Sagittarius, a star-packed region of the Milky Way where the odds of finding something or someone unexpected are tantalizingly high. But here's the real kicker: despite decades of relentless searching, no one has ever found a repeat signal or a plausible natural explanation. We've ruled out satellites, space debris, and earthly interference. Even exotic cosmic phenomena like pulsars or quasars don't fit the profile. The WOW signal was a one-time event, a cosmic flashbulb that left no shadow. This has led to inevitable speculation. Could it have been a deliberate transmission? Some scientists argue that if an extraterrestrial civilization wanted to send a beacon, this is exactly how they do it: brief, unmistakable, and impossible to ignore. Others counter that the universe is vast enough to produce freak anomalies, and we might simply be seeing a rare natural event we don't yet understand. There's even a middle ground theory suggesting the signal could have been bent or amplified by an intervening cosmic lens, like a black hole or neutron star, making a faint natural source appear artificially strong. The frustrating beauty of the WOW signal is its elusiveness. It's a riddle without an answer, a clue without a case. Every attempt to explain it only deepens the mystery, leaving us to wonder whether we caught a fleeting glimpse of something extraordinary, or just the universe playing a trick on us. One thing's certain: until we detect another signal like it, the WOW remains the ultimate cosmic teaser, a whisper from the void that refuses to be forgotten. The Hercules Corona Borealis Great Wall isn't just big, it rewrites the definition of colossal. Imagine a structure so vast it would take light 10 billion years to cross from one end to the other, a sprawling filament of galaxies that dwarfs even the most massive superclusters. This isn't just the largest known structure in the universe. It's a cosmic paradox, a behemoth that shouldn't exist according to our best models of how the universe evolved. Here's why this is so revolutionary. The cosmological principle, a cornerstone of modern astronomy, states that on large scales, the universe should look roughly the same in every direction. Matter should be evenly distributed like foam in a well-mixed latte. But the Hercules Corona Borealis Great Wall throws that assumption into chaos. Discovered in 2013 by mapping gamma-ray bursts the death cries of massive stars. This structure is anything but uniform. It's a dense ribbon of galaxies, galaxy clusters, and dark matter stretching across a staggering tenth of the observable universe. What's truly mind-bending is the timing. Based on our current understanding, structures this massive shouldn't have had enough time to form after the Big Bang. Gravity works slowly, pulling matter together over eons. For something this enormous to exist, either our models of cosmic evolution are missing a critical piece, or the universe had a head start we don't yet understand. Some theorists speculate that exotic physics, like early dark energy or primordial quantum fluctuations, could have seeded these ultra-large structures. Others wonder if we're seeing evidence of multiple universes bumping together, their gravitational fingerprints imprinted on our own, but the plot thickens. The Great Wall isn't just a static relic. It's still growing, still shaping the cosmos around it. The gravitational pull of such an immense structure can warp the paths of nearby galaxies, bending light and redirecting entire galactic flows. It's a gravitational titan, quietly orchestrating the motion of countless stars in its shadow. The more we study it, the clearer it becomes. This isn't just an anomaly. It's a challenge to everything we thought we knew about the universe's architecture. If structures like this can exist, what else is out there, lurking just beyond the limits of our telescopes? The Hercules Corona Borealis Great Wall isn't just a record breaker, it's a cosmic wake-up call, reminding us that the universe has a way of defying even our most carefully crafted rules. And that's the real thrill of discovery, not just finding answers, but uncovering questions we didn't even know to ask. The Red Rectangle Nebula looks like something straight out of a cosmic geometry textbook, a vibrant, almost artificial structure defying the natural chaos of space. Named for its striking appearance in early images, this nebula isn't just a dying star's farewell. It's a masterpiece of symmetry, with two glowing cones of gas and dust meeting at a crisp, right-angled intersection. Most nebulae billow outward in graceful spheres or chaotic tendrils, but this one, it's as if the universe grabbed a ruler and sketched perfect lines across the sky. At the heart of this enigma lies HD 44179, a binary star system nearing the end of its life. As these stars shed their outer layers, they should create a classic planetary nebula, a glowing cloud of ejected material. Yet instead of dispersing evenly, the gas and dust here are funneled into an extraordinary X-shape, with concentric rings stacked like a celestial ladder. The leading theory suggests the star's intense gravitational dance is sculpting the outflow, their orbital motion acting like a cosmic spatula shaping the nebula's strange form. But even that doesn't fully explain the razor-sharp edges or the eerie precision of those nested squares. Then there's the color, a deep, almost unnatural red that comes from a rare form of carbon molecules called polycyclic aromatic hydrocarbons. These complex organic compounds, often found in soot or interstellar dust, glow under the star's ultraviolet light, painting the nebula in hues that feel more like a neon sign than a stellar graveyard. It's a reminder that even in death, stars can create the building blocks of life, scattering organic material into the cosmos. But the real mystery lies in those geometric rings. Some researchers propose they're caused by periodic bursts of material ejected at regular intervals, like ripples from a stone tossed into a pond. Others wonder if magnetic fields, twisting around the binary stars, are corralling the gas into these precise formations. And then there's the wild card. Could we be seeing light itself bent by an unseen disk of dust orbiting the stars, creating an optical illusion of perfect angles? What makes the Red Rectangle so captivating isn't just its beauty, it's the defiance. In a universe that favors randomness, here's a structure that insists on order, challenging our assumptions about how stars die and how matter behaves in the void. It's a cosmic reminder that even the most familiar processes can surprise us, and that somewhere out there, physics might be playing by rules we haven't quite cracked yet. Every time we look at it, we're not just seeing a dying star's final act. We're witnessing a puzzle written in light and dust, waiting for its solution. For decades, rumors have swirled about an enigmatic object silently circling our planet, the so-called Black Knight satellite. This shadowy figure in Earth's orbit has been called everything from ancient alien technology to a secret government spy device, but the truth is far stranger than fiction. The legend began in the 1950s when unusual radio signals were allegedly intercepted, followed by reports of a dark, unidentified object glimpsed during early space missions. Some even claim it's been there for 13,000 years, a relic from an advanced civilization watching over humanity. What makes the Black Knight so tantalizing is its persistence. Unlike typical space debris, which burns up or falls into predictable orbits, this mystery object seems to defy easy classification. Amateur astronomers have occasionally spotted it, or something like it, loitering in polar orbit, an unusual path for human-made satellites. Conspiracy theorists point to grainy NASA photos and intercepted radio bursts as proof of its otherworldly origins, while skeptics dismiss it as a jumble of misidentified space junk, thermal blankets lost during missions, or even fragments of old rocket boosters. But here's where the story twists. In 1998, astronauts aboard the space shuttle Endeavour photographed an odd, tumbling object during a mission. NASA called it a discarded thermal cover, but the image fueled the myth further, its jagged edges and asymmetrical shape looking anything but ordinary. Then there's the infamous, long-delayed echo phenomenon, radio signals that bounce back to Earth seconds after transmission, as if something out there is listening and repeating. Could this be the Black Knight's doing, or just ionospheric quirks playing tricks on our equipment? Scientists have a more grounded explanation. Space is cluttered with decades of debris-defunct satellites, spent rocket stages, even stray bolts, all drifting in a chaotic ballet. The Black Knight is likely a collage of these fragments, their orbits occasionally aligning to create the illusion of a single, purposeful object. Yet, even with Occam's razor in hand, the mystery endures. Why? Because it taps into something deeper, our fascination with the idea that we're not alone, that somewhere in the void something might be watching. Whether it's space junk or something more, the Black Knight satellite serves as a reminder. Sometimes the most compelling mysteries aren't about what's out there, but why we're so desperate to believe in them. And in that sense, the legend, real or not, has already left its mark. The universe has a way of turning even the wildest science fiction into reality, and the Diamond Planet is proof. Officially named PSRJ 1719-1438b, this exotic world orbits a pulsar roughly 4,000 light-years from Earth, and its composition reads like something from a cosmic fairy tale. Imagine a planet so dense, so carbon-rich, that much of its mass has crystallized into actual diamond, not tiny gemstones, but a vast planet-scale lattice of compressed carbon. At 5 times Earth's mass yet only half its diameter, this ultra-dense orb is essentially a celestial jewel, forged under pressures and temperatures beyond anything our solar system could produce. What makes this planet truly extraordinary isn't just its bling, it's the story of its birth. The pulsar it orbits is the corpse of a once massive star that went supernova, leaving behind a rapidly spinning neutron star no larger than a city. Somehow, this diamond world survived the explosion, likely because it was already incredibly dense, possibly the remnant core of a gas giant whose outer layers were stripped away by the dying star. Over eons, the intense gravity and heat transformed its carbon into crystalline structures, turning it into the universe's ultimate treasure chest. But here's the twist. This isn't just a static diamond floating in space. The planet's extreme conditions mean its carbon could exist in forms we've never seen, perhaps layers of diamond giving way to even stranger states, like liquid carbon or exotic superconductors. Some theorists speculate that under such pressure, carbon might form super diamond, a hypothetical material even harder than the diamonds we know. It's a reminder that the universe's chemistry lab operates on scales we can barely fathom, crafting materials that defy our earthly benchmarks. Of course, mining this cosmic gem is pure fantasy for now. With surface temperatures soaring into the thousands of degrees and a gravitational pull that would crush any spacecraft, PSRJ 1719-1438b is less a destination and more a cosmic curiosity. Yet its existence opens thrilling questions. How many other diamond worlds lurk out there? Could carbon-rich planets host even more bizarre materials? And what does it mean for the search for life when planets can be so radically different from our own? The Diamond Planet isn't just a celestial oddity, it's a window into the infinite variety of worlds waiting to be discovered. It challenges our assumptions about what planets can be, proving that the universe's creativity knows no bounds. And while we may never hold a piece of this distant jewel, its very existence sparkles with a different kind of value. The reminder that out there, in the quiet corners of the cosmos, reality is always stranger than we dream. Few cosmic mysteries have sparked as much debate as KIC 8,462,852, better known as Tabby Star. This unassuming flicker in the constellation Cygnus behaves like no other star we've observed, dimming erratically by up to 22% at irregular intervals, sometimes for days or weeks, other times in bizarre, asymmetrical dips that last mere hours. These aren't the clean, periodic shadows of orbiting planets. This is the light curve of something far stranger, something that defies easy explanation. When astronomers first spotted its odd behavior in 2015, the theories flew fast from swarms of comets to interstellar dust clouds. But one hypothesis caught the public's imagination like no other: the tantalizing possibility that we were looking at an alien megastructure, a partial Dyson sphere under construction. The concept of a Dyson sphere, a hypothetical shell of solar collecting panels built around a star to harness its energy, was once pure science fiction. Yet Tabby Star's unpredictable dimming pattern seemed to fit. Imagine a civilization so advanced it could dismantle planets, forging their material into vast energy-harvesting arrays that occasionally block starlight in unnatural ways. The idea isn't as far-fetched as it sounds. Physicist Freeman Dyson himself speculated that such structures would be detectable by their infrared signatures, as absorbed starlight would be irradiated as heat. And here's where it gets intriguing. Tabby Star does show excess infrared emissions, though not quite matching theoretical predictions. But before we jump to extraterrestrial conclusions, nature offers plenty of alternative explanations. One leading theory suggests the star is surrounded by a massive, uneven ring of dust, perhaps debris from a catastrophic planetary collision or the remnants of a swallowed moon. Others propose that the star itself is unstable, with internal dynamics causing erratic brightening and dimming. Then there's the alien comet swarm idea. Thousands of giant, fragmented comets with long, dusty tails passing in front of the star at random intervals. Each theory has merits, yet none perfectly explains all the observations. What makes Tabby Star so compelling isn't just the mystery, it's how it challenges our assumptions. Normally, we expect cosmic phenomena to follow predictable patterns. Planets transit at regular intervals, pulsars flicker with metronomic precision. But Tabby Star dances to its own rhythm, a cosmic jazz improvisation that keeps astronomers on their toes. Every new observation adds layers to the puzzle. In 2017, the star dimmed again, but this time in wavelengths that suggested fine dust was involved. Then in 2021, another dip, this one so sharp and sudden it ruled out most natural explanations. The truth is, we may never know exactly what's happening around this enigmatic star, but that's the beauty of cosmic detective work. Whether it's a swarm of comets, a rogue dust cloud, or something even more extraordinary, Tabby Star reminds us that the universe is full of surprises. And perhaps that's the real lesson here. Sometimes the most profound discoveries aren't about finding answers, but about learning just how many questions are still out there, waiting in the dark. NGC 1277 isn't just another galaxy, it's a cosmic relic frozen in time, a celestial anomaly that astronomers call the Cannibal Galaxy. Nestled 220 million light-years away in the constellation Perseus, this compact but massive galaxy has baffled scientists with its eerie stillness. While most galaxies are bustling stellar nurseries, churning out new stars in swirling arms of gas and dust, NGC 1277 has been dormant for nearly 10 billion years. It's as if the universe hit pause on this galaxy's evolution, leaving it stranded in the distant past while others continued to grow and change. What makes this galaxy so peculiar isn't just its inactivity, it's the sheer violence of its backstory. NGC 1277 is a fossil from the universe's most chaotic era, a time when galaxies clashed and merged in a frenzy of cosmic cannibalism, the leading theory. This galaxy gorged itself on its neighbors so voraciously that it ran out of fuel, devouring every nearby source of star-forming gas until it had nothing left to consume. Imagine a galaxy so hungry it ate itself into a coma, collapsing under the weight of its own appetite. The evidence is written in its stars. Unlike younger galaxies, where stellar populations vary in age, nearly all of NGC 1277 stars are ancient, around 10 billion years old, with almost no new additions since. Its core is dominated by a supermassive black hole so disproportionately large it makes up nearly 14% of the galaxy's total mass, a gravitational dictator that might have stifled star formation by heating or expelling gas needed for new stars. Combine that with its unusually high speed racing through its galaxy cluster at 2 million miles per hour, and you've got a recipe for isolation. NGC 1277 is a galactic hermit, stripped of companions and left to drift in a self-imposed exile. But here's the twist: this galaxy isn't just a museum piece. It's a challenge to our understanding of how galaxies evolve. Current models suggest massive galaxies should still be forming stars today, fueled by fresh gas from cosmic filaments or mergers. NGC 1277 defies that expectation, offering a glimpse into an alternate galactic fate, one where growth isn't guaranteed and feasting can lead to famine. Some scientists even speculate it might belong to a rare class of relic galaxies, pristine time capsules preserving conditions from the early universe. The deeper we look, the more questions arise. Did its black hole's monstrous appetite starve the galaxy, or was it the speed of its movement through the cluster that stripped away its gas? Could there be other galaxies like it lurking in the cosmic shadows, frozen in similar states of arrested development? Every observation peels back another layer, revealing just how complex and unpredictable galactic life cycles can be. NGC 1277 isn't just a curiosity, it's a reminder that the universe has more than one way to press pause on creation itself. And in that stillness, we might just find the keys to understanding how galaxies live, die, and sometimes simply stop. HD 106906b is the exoplanet that shouldn't exist, a gas giant so far from its star it defies every rule of planetary formation. Picture Jupiter, but 11 times more massive, floating alone in the cosmic deep, orbiting its host at a staggering distance of 650 times Earth separation from the Sun. At that range, you'd expect darkness, cold, and silence, but this planet blazes with residual heat, glowing faintly in infrared like a cosmic ember, a remnant of its violent birth. How does something this massive form so far out? Our standard model of planet formation hinges on the idea of protoplanetary disks swirling rings of gas and dust where material clumps together over millions of years. Close to the star, rocky planets coalesce. Farther out, gas giants like Jupiter take shape. But HD 106906b sits in no man's land, nearly 20 times farther from its star than Neptune is from the Sun. At that distance, the disk would have been too sparse, too thin, for a planet this size to gather enough material. It's like finding a skyscraper in the middle of the Sahara. Nothing around it could explain its existence. One radical theory suggests this planet didn't form where it is now. Instead, it might have been born much closer to its star, only to be violently kicked outward by gravitational chaos. Imagine a young solar system as a cosmic pinball machine, with fledgling planets jostling for position. A near collision or the tug of a passing star could have sent HD 106906b careening into the abyss, where it now drifts in gravitational limbo. There's even evidence of a lopsided debris field around the star, hinting at a past cataclysm, perhaps the very event that exiled this world. Then there's the wild card: could it be a failed star? Some astronomers speculate HD 106906b might have formed more like a binary companion, a tiny stellar sibling that never gathered enough mass to ignite. But even that doesn't quite fit. Its chemical composition, temperature, and orbit all point to something stranger, something in between, a celestial misfit that blurs the line between planet and brown dwarf. What makes this discovery so thrilling isn't just the puzzle, it's the implications. If planets can form or be flung this far out, what else lurks in the frozen edges of other star systems? Could there be an entire population of rogue giants drifting unseen in the darkness? HD 106906b forces us to rewrite the textbooks, proving that the universe has more than one way to build a solar system. And out there, in the quiet vastness, other impossibilities are waiting to be found. Tucked away in the vast cosmic tapestry lies a ghost, a galaxy so faint, so ethereal, it barely registers as more than a whisper against the void. Meet Dragonfly 44, the so-called Phantom Galaxy, a cosmic paradox that appends everything we thought we knew about how galaxies form. From afar, it looks like little more than a smudge, a wisp of light containing just 1% the stars of our Milky Way. But here's what makes it extraordinary. This galaxy weighs as much as 1 trillion suns. Where's all that missing mass? The answer is written in darkness. Dragonfly 44 is a galaxy built not on stars, but on the invisible scaffolding of dark matter, a shadowy skeleton holding it together against all odds. This discovery sent shockwaves through astronomy because it shouldn't exist. According to conventional models, galaxies this massive should be dazzling metropolises, packed with stars and glowing gas. Yet Dragonfly 44 is a cosmic ghost town. Its streets nearly empty, its light barely a flicker. The only explanation: dark matter, the elusive substance that makes up 85% of the universe's mass, is doing the heavy lifting here, binding the galaxy together with gravitational glue we can't see. Think of it like a city where the buildings are invisible. You'd see a few scattered street lamps, the stars, but the real structure, the skyscrapers, the roads, the foundations exists in a realm beyond sight. That's Dragonfly 44. Its dark matter halo is so dense, so dominant, that it raises a spine-tingling question. Could there be entire galaxies made purely of dark matter, floating unseen right beside us? Some researchers think so. They've even proposed that these dark galaxies might outnumber the ones we can see, hidden in plain sight like cosmic phantoms. But how do you study something that refuses to be seen? Astronomers had to get creative. By tracking the motions of Dragonfly 44's few visible stars, they could map the gravitational influence of its dark matter, like deducing the shape of a hidden magnet by watching how iron filings dance around it. The results were staggering. This galaxy's dark matter isn't just present, it's in charge, dictating every aspect of its structure and survival. The implications are profound. If dark matter can sculpt galaxies this massive with almost no stars, it means our universe's architecture might be shaped far more by the unseen than the seen. It suggests that dark matter isn't just a passive ingredient, it's an active sculptor, weaving invisible frameworks that determine where and how galaxies form. And if that's true, then the cosmos we've been mapping all these years, the glittering web of galaxies and clusters, might just be the tip of the iceberg. The real cosmic blueprint, it's written in shadows waiting to be decoded. Dragonfly 44 isn't just a curiosity, it's a key, one that might unlock the secrets of dark matter itself. And out there, in the quiet depths of space, countless more phantoms could be waiting, their invisible hands shaping the universe in ways we're only beginning to imagine. Hogue's object is the kind of cosmic oddity that makes you question whether you're seeing an optical illusion, a perfect, ghostly ring of blue stars encircling a golden core, floating in the void like a celestial bullseye. Discovered in 1950 by astronomer Art Hogue, this peculiar galaxy defies every expectation of how galaxies should look. Most spiral galaxies, like our Milky Way, have arms winding outward from a central bulge. Elliptical galaxies are smooth, featureless orbs of ancient stars, but Hogue's object, it's neither. It's a pristine ring with a nearly empty gap between the core and the outer band, a structure so precise it looks almost engineered. What makes this galaxy so baffling isn't just its beauty, it's the mystery of its birth. Normally, ring galaxies form when a smaller galaxy punches through the center of a larger one, sending shockwaves of gas and dust rippling outward in a circular wave of star formation. The famous Cartwheel Galaxy is a textbook example of this violent process, but Hogue's object shows no signs of such a collision. There's no debris, no twisted remnants of a cosmic crash, just this eerily symmetrical ring floating in isolation. It's as if the universe decided to skip the chaos and cut straight to the perfect result. One theory suggests it might be the aftermath of an ancient collision, so perfectly aligned that all traces of the intruder galaxy have long since dissipated, leaving only the ripple of new stars behind. Another idea proposes that gravitational instabilities within the galaxy itself could have triggered the ring's formation, though no model fully explains its razor-sharp edges. Then there's the wild card. Could this be evidence of a phenomenon we've never observed, some rare quirk of galactic physics that only occurs under impossible-to-replicate conditions? The plot thickens when you peer even deeper. Nestled within the gap between the core and the ring, astronomers have spotted another, fainter ring, a ghostly echo of the first, hinting at multiple waves of star formation. Even more intriguing, the core of Hogue's object rotates in the opposite direction of the outer ring, a cosmic contradiction that adds another layer to the puzzle. Perhaps the most tantalizing clue lies in what surrounds this cosmic bullseye. Peering into the darkness behind it, astronomers have found at least 2 more distant ring galaxies, all eerily similar in structure. Could this be evidence of a previously unknown class of galaxies, shaped by some universal process we've yet to uncover? Or is it just a cosmic coincidence, a trick of perspective and timing? Hogue's object is more than just a celestial curiosity. It's a challenge to our understanding of how galaxies evolve. Like a single brushstroke in an otherwise blank canvas, it forces us to confront how much we still don't know about the universe's artistry. Every time we think we've cracked the code of galactic formation, something like this appears, whispering that the cosmos still holds secrets we've barely begun to imagine. And that's the real magic of discovery, not just finding answers, but realizing how many questions remain, waiting in the dark. The loneliest star isn't just drifting through space, it's a cosmic castaway, banished from its galactic home by forces so violent they defy comprehension. Imagine a sun-like star, not nestled safely in a spiral arm or clustered with siblings, but hurtling through the freezing void between galaxies at over 1 million miles per hour. This is no ordinary rogue star. Most stellar drifters get ejected from their own solar systems, but this one was flung clear of its entire galaxy, sentenced to an eternity of solitude in the unimaginable vastness of intergalactic space. What could possibly generate that kind of explosive energy? The leading theory points to a close encounter with the supermassive black hole at the galaxy's core, a gravitational slingshot so powerful it could fling stars clear across the cosmos. Picture this: a binary star system wanders too close to the black hole's event horizon. One star gets captured, spiraling into oblivion, while its companion is catapulted outward at relativistic speeds, like a stone from a cosmic catapult. The math checks out. These black hole ejections can accelerate stars to up to 5% the speed of light, enough to escape even a galaxy's gravitational grip forever. But there's a darker possibility. Some of these intergalactic wanderers might be survivors of ancient galactic collisions, stars torn loose when 2 galaxies grazed each other in a gravitational tug of war. Others could be remnants of long disintegrated dwarf galaxies, their structures shredded by tidal forces, leaving behind only the hardiest stars to drift alone. The loneliest star we've found, designated SDSSJ 1229 plus 1122, is particularly haunting. It's been traveling for billions of years, its light stretched to a dull red by the expansion of the universe itself, carrying no planets, no companions, just the fading memory of the galaxy that once birthed it. Here's what makes these stellar exiles so fascinating. They're more than just cosmic anomalies. They're forensic evidence carrying chemical signatures that reveal their origins. By studying their composition, astronomers can trace them back to specific types of galaxies, like celestial fingerprints pointing home. Some even bear the scars of their violent ejection, abnormally high levels of heavy elements suggesting they were ripped away during the explosive death throes of nearby supernova. The loneliest stars also challenge our understanding of habitability. Conventional wisdom says life needs a stable star in a quiet galactic neighborhood. But what if some of these drifters carried planets with them? Theoretical models suggest a small percentage might retain orbiting worlds, frozen in perpetual night, their atmospheres collapse to icy crusts. Yet deep underground, tidal heating or radioactive decay could maintain liquid oceans, pockets of warmth in the interstellar dark. It's a haunting thought. Entire civilizations could rise and fall around these nomad stars, utterly alone, their night skies devoid of neighboring suns, their existence unknown to any other living thing in the universe. Every time we spot one of these solitary travelers, it's a reminder of the cosmos' untamed power. its capacity to create and destroy, to nurture and abandon. They drift through the void like messages in bottles, carrying stories of galactic upheavals we can only begin to reconstruct. And perhaps most humbling of all, for every one we detect, there are likely millions more, invisible to our telescopes, their light too faint, their journeys too vast. The universe isn't just stars and galaxies, it's also the unimaginable spaces between them, and the lonely souls who cross those deserts, never to return. Most stars get one spectacular exit, a single, cataclysmic supernova that marks the end of their life. But in 2014, astronomers stumbled upon a cosmic anomaly that laughed in the face of stellar mortality. Meet the zombie star, officially known as SN 2014J, a white dwarf that somehow survived not one, but multiple supernova explosions. This isn't just a star refusing to die, it's rewriting the rules of stellar demise. White dwarfs are typically the quiet embers of dead stars, Earth-sized cores of carbon and oxygen slowly cooling over billions of years. But when a white dwarf steals material from a companion star, it can reignite in a thermonuclear inferno, a Type Ia supernova so violent it was thought to leave nothing behind. That's what makes SN 2014J so baffling. Instead of vanishing in a blaze of glory, it flared up again months later, glowing with residual heat as if it had clawed its way back from oblivion. How does a star cheat death like this? One theory suggests the initial explosion might have been a failed supernova, a partial detonation that ejected some material while leaving the core intact. Imagine lighting a firework that fizzles halfway, still destructive, but not enough to obliterate itself completely. Another possibility is that the white dwarf had an unusually strong magnetic field, acting like a cosmic shield that deflected some of the explosion's force. There's even speculation that the star's rotation played a role, spinning so fast it couldn't fully destabilize, like a top wobbling but never quite falling over. But the real puzzle isn't just how it survived, it's what this means for our understanding of supernova. These explosions are cosmic yardsticks, used to measure distances across the universe because their brightness is so predictable. If some white dwarfs can fake their own deaths or detonate in stages, it throws a wrench into decades of astronomical calculations. Suddenly, the universe's measuring tape might have more wrinkles than we thought. And then there's the bigger question, is SN 2014J unique, or are there more zombie stars lurking in the shadows? Every time we think we've mapped the boundaries of stellar life and death, the universe serves up a reminder: some stars don't play by the rules. They flicker, they fade, and sometimes, against all odds, they rise from the ashes to burn again. The zombie star isn't just a celestial oddity. It's a testament to the universe's endless capacity to surprise us, proving that even in death, stars can have a second act. The universe isn't just full of bright, star-studded galaxies. It also harbors cosmic ghosts, shadowy structures that lurk in the darkness, almost unseen. Among these phantoms, none are more puzzling than the so-called dark galaxies, vast collections of gas and dark matter with almost no stars to light them up. Imagine a galaxy-sized cloud, as massive as the Milky Way, but eerily dim, just a whisper of hydrogen gas drifting through the void, held together by the invisible grip of dark matter. These aren't merely faint galaxies, they're cosmic enigmas, challenging everything we thought we knew about how stars and galaxies form. What makes dark galaxies so baffling is their refusal to follow the standard script. In a typical galaxy, gas collapses under gravity, forming dense clouds that ignite into stars. But in these shadowy realms, something has gone wrong, or perhaps something is holding the process back. One leading theory suggests their dark matter halos might be too spread out, lacking the gravitational punch to compress gas into star-forming regions. Another idea points to their isolation. Without nearby galaxies to trigger collisions or tidal forces, their gas might simply drift, too diffuse to ignite. There's even speculation that some dark galaxies could be relics from the early universe, frozen in a primordial state before star formation truly began. The hunt for these elusive objects is like searching for footprints in the dark. Astronomers first caught hints of them in the early 2000s, spotting faint radio waves from hydrogen gas in places where no stars should be. Then came the clincher ultra-deep imaging revealed galaxies like Dragonfly 44, with so few stars that their dark matter outweighed visible matter by a staggering 10,000 to 1. But the real breakthrough came with indirect detection methods. By studying how light from distant quasars filters through these gas-rich regions, scientists mapped entire structures that emit no light of their own, like cosmic silhouettes against the backdrop of the universe. Yet the biggest question remains, why did these galaxies fail? Some might have been born in cosmic deserts, regions so devoid of neighboring galaxies that their gas never got the gravitational nudge needed to collapse. Others could have had their star-forming gas stripped away by intergalactic winds or violent encounters with larger galaxies. Then there's the tantalizing possibility that dark galaxies aren't failures at all, but rather sleeping giants, reservoirs of gas waiting for the right conditions to wake up and spark a frenzy of star birth. The implications are profound. If dark galaxies are more common than we thought, they could be the hidden scaffolding of the universe, silent partners in the cosmic web that shapes galaxy clusters and filaments. They might even hold clues to one of astronomy's biggest mysteries, the nature of dark matter itself. By studying where and how these shadowy structures form, we could finally unlock the secrets of the invisible force that binds the cosmos together. Dark galaxies remind us that the universe doesn't always play by the rules. For every brilliant spiral or blazing elliptical, there might be a ghostly counterpart, a galaxy that chose or was forced to remain in the shadows. And as we peer deeper into the darkness, we're left to wonder, how many more of these cosmic phantoms are out there, silently drifting, waiting to be discovered? The cosmic web is the universe's grand design, a sprawling network of galaxies threaded together by vast, luminous filaments of gas, like celestial highways stretching across the void. But look closer and you'll find something strange. Gaps in the tapestry, regions so empty they defy logic. These cosmic voids aren't just pockets of nothingness. They're some of the most perplexing structures in existence, spanning hundreds of millions of light years with barely a star or galaxy in sight. The question isn't just why they exist, it's whether they're truly as empty as they seem, or if they're hiding secrets beyond our current understanding. Take the Boötes Void, for example, a staggering expanse of space so barren it's earned the nickname the Great Nothing. Stretching over 300 million light-years, it contains only a handful of galaxies, a cosmic desert in a universe that's supposed to be teeming with matter. According to our best models, voids this large shouldn't exist. The distribution of matter after the Big Bang should have left space more evenly populated, like foam in a well-stirred latte. Yet here we are, staring into a void so vast it makes our own Milky Way feel like a speck of dust. What's lurking in these empty regions? One possibility is dark energy, the mysterious force accelerating the universe's expansion. It might be pushing matter apart in these voids, clearing out galaxies like a cosmic broom. But there's a catch. Dark energy should act uniformly across space, not carve out specific, irregular voids. Another theory suggests these empty regions are filled with dark matter, the invisible glue holding galaxies together. If dark matter clumps in unexpected ways, it could create gravitational shadows where normal matter never accumulates. Then there's the wildest idea of all, that some voids are evidence of collisions with other universes, their impact zones scrubbed clean of galaxies in the aftermath. The truth might be even stranger. Recent observations hint that these voids aren't completely empty. They're threaded with faint, wispy filaments of gas too diffuse to form stars. These ghostly tendrils could be the remnants of ancient cosmic rivers, channels where matter once flowed before being siphoned away by larger structures. Some voids even emit faint radio signals, whispers of activity that suggest something, perhaps exotic particles or unseen magnetic fields, is at work in the darkness. The most tantalizing clue lies in the cosmic microwave background, the afterglow of the Big Bang. Maps of this ancient light show subtle temperature dips aligned with some of the largest voids, as if these regions absorbed energy from the early universe. That's not supposed to happen. If voids are just empty space, they shouldn't leave fingerprints in the oldest light we can see. Unless, of course, they're not empty at all, but filled with something we don't yet have the tools to detect. These cosmic gaps aren't just blank spots on the map, they're puzzles waiting to be solved. Every void we study forces us to question our assumptions about how matter organizes itself, how gravity shapes the cosmos, and even what the universe is made of. They remind us that emptiness isn't always what it seems. Sometimes the quietest corners of space hold the loudest secrets, and until we peer deeper into the dark, we won't know what's truly hiding in the voids, or what they're trying to tell us about the universe's hidden blueprint. At the edge of the observable universe, where light has traveled nearly 13 billion years to reach us, lurks a cosmic paradox. A quasar are so impossibly ancient it threatens to upend our understanding of black hole formation. Meet ULA's J1342 plus 0928, a supermassive black hole weighing in at 800 million times the mass of our Sun, shining with the brightness of 1,000 galaxies. The shocking part, it existed when the universe was just 690 million years old, a cosmic toddler by universal standards. That's like finding a skyscraper in the ruins of a civilization that had only just discovered the wheel. It shouldn't be there, not yet, not according to everything we thought we knew. How does something this massive form so quickly? Current models suggest black holes grow gradually, starting as modest stellar remnants that gorge on gas and merges over billions of years. Even the most optimistic simulations struggle to explain how ULA's J1342 plus 0928 packed on so much weight in less time than it takes most galaxies to form their first spiral arms. One radical theory proposes these early black holes didn't grow from stars at all. They might have been born big, collapsing directly from primordial gas clouds so dense they bypassed the star stage entirely. Picture a cosmic shortcut where the universe's first black holes were forged in the chaos of the Big Bang itself, seeded by quantum fluctuations frozen into the fabric of spacetime. Then there's the light problem. Quasars like this one aren't just black holes, they're active monsters, surrounded by superheated accretion disks that glow brighter than anything else in the cosmos. But to shine that fiercely, they need fuel, and lots of it. The early universe was supposed to be a sparse, gas-poor environment, with matter too thinly spread to feed such a ravenous beast. Yet here's ULA's J1342 plus 0928, burning at full tilt, suggesting it found a way to tap into reservoirs of matter we didn't know existed. Some astronomers speculated could have been sitting at the crossroads of ancient cosmic filaments, where rivers of gas flowed into its maw like water down a drain. Others wonder if it cannibalized entire protogalaxies in a feeding frenzy we've never witnessed before. The implications are staggering. If black holes this colossal existed so early, they might have played a far greater role in shaping the universe than we ever imagined. Their radiation could have ionized the first atoms, ending the cosmic dark ages and lighting up the cosmos for good. Their gravity might have dictated where galaxies formed, sculpting the large-scale structure of everything we see today. And if they really were born massive, not grown, it means our universe's rulebook for black hole formation is missing entire chapters. What's truly humbling is that Euler's J1342 plus 0928 might not even be the outlier we think it is. As telescopes peer deeper into the cosmic dawn, they're finding more of these impossible quasars, each one a ticking time bomb for current theories. Every discovery pushes the boundary of too early further back, forcing us to confront an uncomfortable truth. The universe's infancy might have been far wilder, far more extreme than our models can handle. And until we crack the code of these cosmic anomalies, we're left staring into the abyss not just of space, but of our own understanding. Imagine a supermassive black hole, an object so heavy it anchors entire galaxies, suddenly ripped from its home and flung into the void at speeds reaching 5 million miles per hour. This isn't science fiction. It's the jaw-dropping reality of runaway black holes, cosmic outcasts ejected with such violence that their escape paths defy comprehension. The forces behind these events are so extreme, they stretch the limits of known physics. Take the case of a black hole designated 3C186, first noticed when astronomers spotted a superheated trail of gas blazing across interstellar space like a cosmic exhaust plume. Normally, supermassive black holes sit motionless at galactic centers, their immense gravity holding everything in orbit, but this one was different. It was moving fast. Further observations revealed the unthinkable. It had been catapulted from its host galaxy, leaving behind a wake of shocked gas and orphan stars. The energy required to dislodge a black hole weighing millions of suns is staggering, equivalent to 100 million supernova exploding in perfect unison. So what could possibly generate that kind of power? The leading theory points to a gravitational slingshot effect during galactic collisions. Picture two galaxies merging, their central black holes spiraling toward each other in a deadly dance. As they merge, the titanic gravitational waves produced could kick the newly formed black hole in one direction like a cosmic recoil. But there's a catch. For the black hole to escape entirely, the kick would need to surpass the galaxy's escape velocity, something once thought impossible for objects this massive. Yet the evidence is right there in the data. Some black holes break free, proving the universe can unleash forces beyond our wildest calculations. Even stranger is what happens in their wake. As these rogue black holes barrel through intergalactic space, they don't travel alone. Their gravity drags along clusters of stars torn from their original galaxy, creating eerie, hypercompact stellar systems, tiny, dense entourages of stars orbiting nothing visible. To an observer, it would look like a group of stars orbiting empty space, their paths betraying the presence of an invisible monster in their midst. Some of these black holes might even drag streaks of glowing gas, lighting up the darkness like ghostly lighthouses as they roam the void. The implications are profound. If black holes can be ejected, it means galaxies might lose their gravitational anchors, potentially disrupting their evolution. It also raises spine-tingling questions. Could our own Milky Way's supermassive black hole, Sagittarius A, ever suffer such a fate? The odds are vanishingly small, but the fact that it's possible at all reshapes how we think about galactic stability. What's truly humbling is that these runaway giants might be more common than we realized. With improved telescopes, astronomers are spotting more of these exiles. each one a testament to the universe's capacity for violence on a scale we're only beginning to grasp. They remind us that even the most dominant forces in the cosmos aren't immune to chaos, and that somewhere out there, a black hole millions of times heavier than our sun is drifting alone through the eternal night, carrying the scars of a home it can never return to. The Methuselah Star, officially known as HD 140283, is the cosmic equivalent of finding a grandfather clock ticking away in the ruins of an ancient civilization, except this clock might actually predate the ruins themselves. Initial measurements of this unassuming yellow subgiant, located just 190 light-years from Earth, sent shockwaves through the astronomy community when they suggested it was a staggering 16 billion years old. There's just one problem. The universe itself is only 13.8 billion years old. That's like discovering a birth certificate listing a child's age as older than their parents. How does a star defy the very timeline of existence? The answer lies in the delicate art of stellar archaeology. Unlike most stars, which blur their origins by recycling material from earlier generations, Methuselah is a rare population 2 star, a relic from the universe's youth, composed almost entirely of hydrogen and helium with barely a trace of heavier elements. This purity makes it a pristine time capsule, but dating it requires piecing together clues from its brightness, composition, and nuclear activity. Early estimates relied on the assumption that its low metal content meant it formed before later stars seeded the cosmos with heavier elements. But here's where things get messy. Revised analyzers using advanced models and data from the Hubble Space Telescope adjusted Methuselah's age downward to around 14.5 billion years, still uncomfortably close to the Big Bang, but now with a margin of error that barely keeps it within cosmic limits. The key adjustment, accounting for oxygen levels in the star, which earlier studies underestimated. Oxygen acts like a cosmic speedometer for stellar aging. More of it means the star burns slightly faster, shaving off eons from initial estimates. Yet, even with these corrections, Methuselah remains an outlier, hovering at the very edge of plausibility. But the real intrigue isn't just the star's age, it's what its existence implies about the universe's earliest moments. If Methuselah truly formed within a few 100 million years of the Big Bang, it challenges our understanding of how quickly stars could ignite in the primordial cosmos. Current models suggest the first stars didn't coalesce until at least 100 million years after creation, yet Methuselah's potential birth date nudges that timeline into uncharted territory. Some theorists speculate it might have formed in an unusually dense pocket of the early universe, where gravity worked overtime to collapse gas into stars faster than expected. Others wonder if our measurements of the universe's expansion rate, which directly affects age calculations, might need another tweak. Then there's the tantalizing wildcard. Could Methuselah's extreme age hint at gaps in our understanding of stellar physics itself? Stars this ancient burn differently than their modern counterparts, with fusion processes that might operate under rules we haven't fully decoded. Its peculiar pulsations, observed by precision instruments, suggest internal structures that don't perfectly align with standard models. It's almost as if the star is whispering secrets about a lost chapter of cosmic history, one where the laws of physics played by slightly different rules. What makes Methuselah truly extraordinary isn't just the number attached to it, it's the reminder that the universe's timeline might be more flexible, more mysterious than we've dared to assume. Every time we think we've pinned down the dawn of creation, an ancient sentinel like this one emerges, forcing us to revisit our assumptions. Whether it's a statistical anomaly or a key to rewriting cosmic history, one thing's certain: this star isn't just old. It's a living challenge to everything we thought we knew about time itself. The Great Attractor isn't just a gravitational mystery, It's a cosmic puppeteer, silently tugging thousands of galaxies, including our own Milky Way, toward a point in space we can't even see. Hidden behind the dense star fields and dust of the Milky Way's galactic plane, this enigmatic force reveals itself only through the motion of galaxies, all streaming in the same direction at speeds exceeding 1 million miles per hour. It's as if the universe has a hidden director orchestrating a grand, unseen dance, and we're just beginning to glimpse the choreography. What makes this phenomenon so unsettling is its invisibility. Normally, colossal gravitational pulls come from visible structures, galaxy clusters, superclusters, or massive black holes, but the Great Attractor defies that logic. Observations suggest it contains the mass of tens of thousands of Milky Ways, yet traditional telescopes struggle to pinpoint its source, the culprit. Our own galaxy's dusty disk blocks our view, leaving us to piece together clues from the motions of galaxies around us, like detectives reconstructing a crime scene from scattered fingerprints. The first hints emerged in the 1970s when astronomers noticed something odd. Galaxies in our cosmic neighborhood weren't just drifting apart with the universe's expansion. They were also sliding sideways, pulled toward a mysterious focal point in the constellation Centaurus. Further studies revealed this motion wasn't local. Entire galaxy clusters spanning hundreds of millions of light-years were caught in the same inexorable flow. The scale was staggering. Whatever lay at the center of this pull had to be one of the most massive structures in the observable universe. So what's lurking behind the veil? One leading theory points to the Norma cluster, a dense gathering of galaxies about 250 million light-years away, as the heart of the Great Attractor. But here's the twist. Even this colossal cluster doesn't fully account for the gravitational tug we're observing. Some researchers speculate that the true source might be something even grander, a supercluster of galaxies so vast it dwarfs anything in our immediate cosmic vicinity. The Shapley supercluster, lying 650 million light-years beyond the Great Attractor, could be the real heavyweight, its gravity amplifying the pull we feel from afar. Then there's the wild card, dark flow. Some galaxies are moving even faster than the Great Attractor can explain, hinting at something beyond our observable horizon, perhaps an unfathomably large concentration of mass, or even the gravitational influence of another universe brushing against our own. It's a chilling thought. The Great Attractor might not be the final destination, but just one stop on a cosmic conveyor belt leading to something even more immense and unseen. What's truly humbling is how much we still don't know. New instruments like radio telescopes and infrared observatories are peeling back the Milky Way's dusty curtain, revealing faint galaxies and structures previously hidden. Each discovery adds another piece to the puzzle, but the full picture remains elusive. The Great Attractor isn't just a scientific curiosity. It's a reminder that even in our own cosmic backyard, the universe holds secrets we've barely begun to uncover. And as we stare into the void, pulled toward the unknown, we're left to wonder, what other invisible giants are out there shaping the cosmos in ways we can't yet see? Galaxies are supposed to play by certain rules, chief among them, the invisible hand of dark matter guiding their formation and holding them together. But NGC 1052DF2 isn't just breaking the rules, it's tearing up the cosmic rulebook entirely. This bizarre, ghostly galaxy drifting 65 million light-years away is missing something fundamental, the very dark matter that should make up the bulk of its mass. Imagine building a skyscraper without steel beams, or a living body without bones. That's the level of impossibility we're dealing with here. The discovery sent shockwaves through astrophysics because dark matter isn't just a minor ingredient in galactic recipes, it's the scaffolding. According to prevailing theories, galaxies form when dark matter's gravitational pull gathers gas and stars into its invisible embrace. Without it, ordinary matter shouldn't clump efficiently enough to create stable structures. Yet here's NGC 1052DF2, a sprawling, diffuse galaxy with barely any dark matter at all, its stars moving so sluggishly that they should have drifted apart eons ago. It's like finding a car speeding down the highway with no engine, defying every law of celestial mechanics. So how does something like this even exist? One provocative theory suggests it might be the aftermath of a cosmic hit and run. Picture this: a smaller galaxy plunges through a larger one, and the gravitational turbulence strips away its dark matter like a thief in the night, leaving behind only the visible stars. Alternatively, some propose that intense bursts of star formation could have blown out the galaxy's dark matter, like cosmic winds clearing fog from a valley. But neither explanation fully accounts for the sheer emptiness of NGC 1052DF2's dark matter halo, or the fact that we've since discovered a handful of other galaxies with similarly missing mass. The implications are staggering. If galaxies can form and persist without dark matter, it means our understanding of their birth, and by extension, the universe's structure, is incomplete at best, flawed at worst. Maybe dark matter isn't the universal glue we thought it was. Perhaps there are multiple paths to galaxy formation, some involving exotic physics we haven't yet uncovered. Or, most tantalizing of all, could these oddballs be evidence of an entirely new type of dark matter, one that interacts differently with the cosmos or doesn't interact at all? What's truly exhilarating is how this discovery flips the script. For decades, astronomers used discrepancies in galactic motion as proof of dark matter's existence. Now they're staring at galaxies where those discrepancies vanish, forcing them to ask, is dark matter more complex than we imagined, or are we witnessing the cracks in the theory itself? NGC 1052DF2 isn't just a cosmic anomaly, it's a dare, a challenge to look deeper, question harder, and admit that the universe still holds surprises capable of upending even our most cherished assumptions. And in that uncertainty lies the thrill of discovery, the realization that every answer we find might just lead to a bigger, more beautiful question. The cosmic microwave background is supposed to be the universe's ultimate fingerprint, a near-perfect snapshot of the early cosmos, uniform in every direction. But in 2005, astronomers stumbled upon something that shattered that assumption. An eerie alignment in the ancient light's temperature fluctuations, stretching across the sky like an invisible axis. Dubbed the axis of evil by skeptical scientists, this pattern points to a spine-tingling possibility that the universe might have a preferred direction, a cosmic North Star that defies everything we thought we knew about space's fundamental symmetry. At the heart of the controversy is the cosmological principle, the bedrock idea that the universe is isotropic, meaning it should look the same in all directions, with no special location or orientation. The cosmic microwave background's near uniformity has long been its strongest evidence, but the axis of evil paints a different picture. When researchers mapped the CMB's temperature variations, they found that hotter and colder spots weren't randomly scattered. They aligned along a specific plane, as if the universe had quietly drawn a line in the sand and dared us to notice. The statistical odds of this happening by chance, less than 1 in 1,000. Some theorists argue this might be an illusion, a trick of perspective caused by our solar system's motion through the cosmos. As we hurtle through space, the Doppler effect could subtly stretch and squeeze the CMB's light, creating false patterns. But here's the catch: when astronomers corrected for our movement, the axis didn't vanish. It stubbornly remained, whispering that the anomaly might be real. Others suggest foreground interference, dust in our galaxy, or undiscovered structures bending the CMB's light like a funhouse mirror. Yet, even after accounting for every known contaminant, the signal persists, gnawing at the edges of our understanding. Then there's the radical interpretation that the universe truly isn't isotropic. If the axis of evil is real, it could mean the Big Bang wasn't perfectly symmetrical, leaving behind wrinkles in space-time that never fully smoothed out. Some models even speculate about pre-Big Bang physics, an earlier phase of existence that imprinted a directional bias on the cosmos, like a cosmic watermark. The most unsettling possibility, that we're seeing evidence of a multiverse, with neighboring universes tugging at ours like invisible magnets, leaving gravitational scars in the CMB. What makes this discovery so electrifying isn't just the scientific debate, it's the philosophical stakes. If the universe has a preferred direction, it upends centuries of assumptions about the fundamental nature of reality. Suddenly, the cosmos isn't just an endless, featureless expanse. It might have hidden architecture, a silent axis around which everything subtly rotates. And until we crack this code, we're left staring at the sky, wondering if the universe is whispering its secrets or if we're just hearing echoes of our own unanswered questions. In the vast silence of deep space, where radio waves usually whisper the faint signatures of distant stars and galaxies, astronomers have stumbled upon something that roars mysterious, colossal rings of radio emission, so vast they could swallow entire galaxies whole. These enigmatic structures, dubbed odd radio circles or ORCs, appear as perfect halos when viewed through radio telescopes, stretching up to a staggering 1,000,000 light-years across. That's 10 times the diameter of our Milky Way, yet they emit no visible light, no X-rays, no trace of their existence in any other part of the spectrum. It's as if the universe has drawn giant, invisible bullseyes in the void, and we're only just learning to see them. The first ORC was discovered in 2019 by astronomers reviewing data from Australia's ASCAP radio telescope, and the initial reaction was sheer disbelief. These rings were too symmetrical, too isolated, and far too large to fit any known cosmic phenomenon. At first, some speculated they might be artifacts, ghostly imprints left by glitches in the telescope's software or interference from earthly sources. But as more ORCs were spotted, their reality became undeniable. These weren't technical errors, they were genuine cosmic mysteries etched into the fabric of space itself. One leading theory suggests these rings could be the aftermath of titanic galactic collisions, where shock waves from merging supermassive black holes ripple outward like cosmic tsunamis, accelerating particles to near light speeds and creating these immense radio halos. Imagine two galaxies slamming together, their central black holes spiraling in a death dance until they finally merge, unleashing a gravitational shockwave powerful enough to sculpt the surrounding gas into a perfect sphere of radio emission. It's a compelling idea, except for one hitch. Most ORCs aren't centered on any visible galaxy, leaving their potential trigger events frustratingly invisible. Then there's the more radical possibility that ORCs are signatures of entirely new physics. Some theorists propose they could be the imprint of wormholes, hypothetical tunnels through space-time whose mouths emit intense radiation as they stabilize. Others wonder if they're evidence of dark matter annihilations, where invisible particles collide and release bursts of energy detectable only in radio waves. The wildest hypothesis, that these circles are the remnants of gargantuan stellar explosions, far larger than any supernova we've witnessed, perhaps from stars in the early universe so massive they defy our current understanding of stellar limits. What makes ORCs especially tantalizing is their potential to rewrite cosmic rulebooks. If they're caused by known phenomena like galactic mergers, they'd still represent a previously unseen phase of galactic evolution, one that unfolds on scales we've never observed. But if they're something entirely new, they could open doors to physics beyond the standard model, hinting at forces or particles we've yet to discover. Every new observation deepens the intrigue. Some ORCs appear to contain galaxies at their centers, but with no visible signs of disturbance. Others float in perfect isolation, their origins untethered to any visible structure. As radio telescopes like the Square Kilometre Array come online, astronomers are racing to uncover more of these ghostly circles, hoping to piece together their story. Each discovery peels back another layer of the mystery, revealing just how much we still don't understand about the universe's most dramatic events. ORCs aren't just cosmic oddities, they're a challenge, a reminder that even in an era of unprecedented discovery, the universe still holds colossal surprises waiting in the quiet static between the stars. And somewhere in that static, the truth about these radio rings is broadcasting, if only we can learn to listen. KIC 8,462,852 isn't just another twinkle in the sky, it's a cosmic enigma that refuses to play by the rules. This unassuming star in the constellation Cygnus, better known as Tabby Star or Boötes Star after its discoverer, behaves like nothing else in our celestial records. Most stars dim in predictable rhythms, perhaps a planet passing in front, or the steady pulse of internal stellar activity. But Tabby's star, it flickers erratically, plunging in brightness by up to 22% at irregular intervals before snapping back to normal. These aren't clean, symmetrical dips like a planet's transit. They're jagged, asymmetrical, almost chaotic, as if something vast and uneven is drifting between the star and Earth, blocking its light in ways nature never intended. The most tantalizing possibility, the one that set the internet ablaze when this star was first studied in 2015, is that we might be looking at alien engineering on an unimaginable scale. Specifically, a Dyson swarm, a hypothetical megastructure built by an advanced civilization to harness a star's energy. Imagine millions of solar collecting panels orbiting their sun, arranged in dense clusters that occasionally block starlight as they pass our line of sight. It's a concept straight out of science fiction, yet the math almost fits. The star's light patterns don't match any known natural phenomenon, and its infrared emissions, though not perfectly aligned with Dyson swarm predictions, show just enough excess heat to keep the theory alive. But before we draft first contact protocols, nature offers its own compelling alternatives. One leading explanation involves swarms of giant comets, not the tidy, icy visitors we know from our solar system, but colossal fragments surrounded by clouds of fine dust. If hundreds of these mega-comets orbited Tabby Star in tight formation, their dusty tails could explain the irregular dimming. Another theory points to an enormous, lopsided ring of debris, perhaps the remnants of a catastrophic planetary collision, casting uneven shadows as it slowly rotates. There's even speculation about internal stellar dynamics, rare magnetic phenomena or star spots, so vast they distort the star's entire light curve. What makes this mystery so enduring isn't just the aliens or not debate, it's how the star keeps surprising us. In 2017, it dimmed again, but this time astronomers caught the event in multiple wavelengths. The dimming was less pronounced in infrared than in visible light, a smoking gun for fine dust particles, exactly what you'd expect from comet debris, not solid megastructures. Yet just when the case seemed closed, 2021 brought another dip, this one so sharp and sudden it defied dust-based explanations. It's as if the star is toying with us, offering clues that lead in circles, ensuring no theory ever feels complete. Underlying all this is a profound scientific lesson. Tabby Star forces astronomers to confront the limits of their categories. Normally, cosmic phenomena fit neat classifications: variable stars, transiting planets, pulsars, each with predictable behaviors. But this star belongs to no known group. Its very existence whispers that the universe might be far stranger, far more inventive than our textbooks suggest. Whether it's aliens, comet swarms, or something entirely new, one thing's certain: KIC 8,462,852 has rewritten the rules of stellar observation. And somewhere in its flickering light, whether natural or engineered, lies a truth that could reshape how we see our place in the cosmos. From cosmic voids to rogue black holes, the universe's quietest regions are teeming with enigmas that push the boundaries of science. Each discovery raises new questions, proving that the more we explore, the less we truly know. What other secrets lie hidden in the darkness? Stay curious, keep looking up, and who knows, maybe you'll be the one to solve the next great cosmic mystery. Consider this: every time we point a telescope at what seems like empty space, we uncover something extraordinary. The Boötes Void taught us that even nothingness holds clues. Fast radio bursts reminded us that the cosmos is alive with invisible chatter. And the Great Attractor, it's proof that some forces are so vast we can only sense their pull, not their source. These aren't just anomalies, they're invitations. The universe is practically daring us to dig deeper, to question harder, to rethink what's possible. But here's the real kicker. For every mystery we've named: Tabby Star, the Phantom Galaxy, the axis of evil, there are countless others waiting in the wings. Unexplained radio signals, flickering quasars, gravitational anomalies that defy logic. Somewhere out there, buried in petabytes of unprocessed data, or hidden just beyond the reach of our instruments, lies the next revelation. Maybe it's a galaxy made entirely of dark matter. Maybe it's a black hole older than time itself. Or maybe, just maybe, it's something so bizarre we don't even have the vocabulary to describe it yet. That's the thrill of cosmic exploration. The answers we've found so far are astonishing, but they're just the prologue. The universe's quietest corners aren't empty. They're stages set for the next act, where the laws of physics might bend, where the familiar gives way to the extraordinary. And the best part, you don't need a PhD to be part of the discovery. Citizen scientists have spotted pulsars in their backyards. Amateur astronomers have tracked asteroids that professionals missed. The cosmos doesn't care about credentials, it rewards curiosity. So here's the challenge: don't just wonder, dive in. Follow the work of researchers pushing boundaries. Join online communities analyzing telescope data, or simply step outside on a clear night and let your eyes adjust to the dark, because the next great cosmic revelation might not come from a lab or a satellite. It could start with a question, a hunch, or a single curious mind staring up at the stars, refusing to accept that the universe has given up all its secrets. After all, the greatest discoveries begin with two simple words: what if? And somewhere out there, in the silence between the stars, the next what if is waiting.